Right. Oh, not just yet. So I got a couple of things I need to do. All right, so welcome YouTube. Yes, it looks like everything is working properly. Probably have to turn this down. Let me see. Okay, that sounds good. All right, so I hope everyone is doing well. You got a visitor. Okay, hang on. Let me grab this. Come on. Come on. All right. Hang on. Come on. Come on. There you go. All right. So Malachi decided. Our TA decided to join us today. I think she was feeling whatever, so she's gonna join us. It just helps to kind of keep her calm and so that we can do what we need to do. So this will be our presentation for, this is week 2, Friday, for support for college algebra. A few notes to my students. Let me see. One, I hope everyone is doing well, okay? Hopefully you're able to access everything. You're able to keep your mind clear, stay calm, and just, things are what they are, but everything that has a beginning has an end. So this too shall pass. This too shall pass, all right? So a few announcements. One, exam 1 is available via Pearson. If you're still having difficulty accessing the material via Pearson, contact me, reach out to me, all right? So either email me. I think I do have my Collaborate session, the audio open right now. So I am kind of listening to see if anybody chimes in to get my attention. I do monitor the live chat on YouTube, so you can actually type into the live chat. But yeah, just email me. You can actually call my office phone. Those calls get through as well during all of this. Let's see. So, but again, exam 1 is available via Pearson. It is due this Saturday, which is tomorrow, by 11:59 p.m. It should take you anywhere from 40 minutes to an hour to go through it, something like that. But you get unlimited attempts. You get unlimited attempts while it's available. Okay. So you want to do the best you can to get it submitted by this Saturday by 11:59, and I think it's very doable. I think you can do it. I think it's only over chapter 1, whatever the first thing that we did. Okay, I try to keep it as light as possible, and I can't think of anything else there. So as you watch these videos, again, take notes as if you're in class. As questions arise, write them down, and then email them to me or things of that nature. Also, as you go through the homework via Pearson, say you're working an example and you get stuck. Each question has a little toolbar in the upper right-hand corner. I guess for your screen, it might be in that direction. Each question on Pearson has a little icon in the upper right-hand corner called the question help. And in there, there's a view and example, which I definitely recommend using. Also, make use of the Ask My Instructor. So as you have questions on your homework for Pearson, make use of the Ask My Instructor. It'll send me a screenshot of the very question you're working on. I'm going to load it to my tablet like you see right now. And I usually make dedicated YouTube videos for students that ask questions. This is for all of my students. I mean, no matter what class you're in, I can do dedicated YouTube videos walking you through it. Let's see. You should be able to get full access, again, with the social climate that's going on. Since we were forced to be online, companies like Pearson and these other companies are offering their services complimentary. So if you're one of my students and you still have temporary access, there's an actual full access code in our announcement section on Moodle. So that also reminds me that be sure that we are forwarding our GMC emails to whatever email we check on a regular. So my main mode of communicating with you all is through announcements, and so it's going to send it to your GMC email. So you definitely want to make sure that those emails are being forwarded. Also, it's also a good idea to go ahead and subscribe to my YouTube channel and turn your notifications on, so that way when I go live or I do video responses. I actually had a student ask a question last night and I responded, and I loaded the video like about 10. He actually emailed me while I was wrapping up the video, and I replied. I think the link that I sent him it didn't go through via email because whatever email was there just was not working. But had he had his notifications on, whenever it was posted, he would have got a notification and he would have saw the response. So I just say that to say, it's a good idea, again, at least for while you're one of my students. Once you leave and you're not my student any longer, if you want to unsubscribe, I totally get it. But while you're my student, it's definitely a good idea to go ahead, again, like, share, and subscribe to my YouTube, and make sure your notifications are turned on, so that way when I post videos, you get a notification. Either you decide if you're going to click on it or if you're going to ignore it, right? Okay, I can't think of any other pertinent information, okay, but we're getting into the rhythm, okay? So also I think I did some starfish reports, so I'm doing my best to try to reach out. I did a few phone calls, so and I usually leave a message because I usually don't answer calls when I don't recognize the number. I don't answer those either. But I try to leave a message and try to be available. Okay. Best times to contact me. I mean, obviously, email. You can call anytime. You can actually call my office phone. If it gets through, it gets through. But you can call the office phone during office hours. I usually answer. And you can actually reach out during class time. My goal is to get these videos pre-recorded so that way during class time I could just be available for questions. But for right now, since this is my first time going through this material with you all, I have to do it. I decided to just go ahead and go live during class time so that way I can kind of honor the time. And then going forward, the videos will be there. Then I can be available or whatever. Okay, so I can't think of any other announcements. So we're going to actually move forward with the material. Okay. So we're going to actually move into chapter 5, okay, on factoring. So I think we're going to, my intent is to go through sections 5.1 to 5.4 all today. So this is a recap or an introduction to factoring. I will make sure that assignments are posted corresponding to this on Pearson. And again, exam 1 is available on Pearson. Let me do a quick glance, because I think that stuff should be there. Let me glance really quickly at Pearson. So I need to go, let's open up Chrome. I just want to glance at my Pearson. Let's go there. Okay. Support for College Algebra 009. All right, so let's go here actually. So let's just do a quick view of Pearson. So when you log in, you should see something that looks like this, right? So we see that, yeah. So you see the assignments 1-3, chapter 1 is there with the due dates, right? We had some assignments due last Saturday. We have some assignments due this Saturday. And we see exam 1 also due this Saturday. So it's all pertaining to chapter 1. We have some other things with chapter 2 due this Saturday, but the main thing is exam 1 for chapter 1. That's due this Saturday by 11:59 p.m. We have other assignments that we've been talking about throughout the week that are due. It looks like a lot, but honestly, these things go by real quick. Like a lot of these assignments take about 10 or 15 minutes. They should, right? And so today, again, I think last time we went through pretty much chapter 2. So today we want to do our best to go to chapter 3. I probably won't do chapter 10, right? I'm probably just going to limit it to chapter 5 and just focus on that, okay, for today. So yeah, we'll just focus on chapter 5. I'll probably change the due dates for chapter 10 to a later date, okay? But today I just want to focus on 5.1 to 5.4, so you can see it there on Pearson. Go back here, okay? So again, usually if we were meeting together, I would pause at this moment to pause for the cause, to see if we're all aboard or if we're all bored. All right. Hopefully, as one of my advisors, my current, he'll say, "Are we all aboard or are we all bored?" It's a shout out to the Lighten Collective. I said that's a fantastic group. Very fantastic, very powerful, very positive, uplifting individuals. I totally miss going to these sessions. There have been attempts to move the sessions to online. It's not the same as being in person, but it is. I am grateful that we at least have the opportunity to connect in this way during the climate. But anyway, moving forward. So chapter 5, we want to take some time to go through these sections on factoring. We're just going to do just chapter 5 for today, and then we'll call it a day. Let's see. Are you working? Okay. So we're going to start with section 5.1, factoring a monomial from a polynomial. Okay, monomial. So some objectives here are, and we can actually turn this off. It's a little bit chilly. Gotta get some water. And I'm gonna do one other thing. I'm actually a little bit chilly. Turn on my heat. Come on. There we go. Okay. So some objectives here are: 1, we want to identify what do we mean by factors. 2, we want to determine the greatest common factor of 2 or more numbers. 3, we want to determine the greatest common factor of 2 or more terms. And then 4, we want to factor a monomial from a polynomial. So to factor an expression means to write the expression as a product of its factors. In general, A times B equals C, then A and B are called factors of C. So factors are things that we multiply, okay, and terms are things that we add and subtract. Factors are things that we multiply, and terms are things that we add. So since A times B in this context are going to equal C, A and B are called the factors of C. Okay, list the factors of 6x cubed, right? So what's being multiplied in the first one? The 6 is being multiplied by the x, right? So we're saying, oh, so notice that all of these are 6x cubed, but we can write 6x cubed expanded in multiple ways. We can rewrite it as what, x times 6x squared to give us 6x cubed. All of these are different ways of writing the same thing. It's the same. So 6x cubed is 1 times 6x cubed, 2 times 3x cubed, 3 times 2x cubed, and 6 times x cubed, right? Let's see. We can also factor out 1x, or let me see, what's the pattern here? Oh, we can do 1x times 6x cubed. These are just different ways of doing the same thing. So the factors of 6x cubed are 1, 2, 3, 6x, 2x, 3x, 6x, x squared, 2x squared. So these are all the different ways that we can multiply to give us 6x cubed. The opposite or negative of each of these is also called a factor, but these opposites are generally not listed unless specifically requested, right? So let's see if we can kind of do this on our own. So we have all the factors, 1, 2, 3, 6. We have x, x squared. So we take all the factors of the 6 times all the factors of our variable, and we do all the combinations between them. So let's see, can we get it going? Okay, let's see this one. So a prime number is an integer greater than 1 that has exactly 2 factors, 1 in itself. The first 15 prime numbers are listed. We have 2, 3, 5, 7, 11, 13, 17, blah, 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 blah. A composite number is an integer greater than 1 that is not prime. Okay, so the first 15 composite numbers are 4, 6, 8, right? Because the factors of 4, you have what? 1, 2, 4, right? So it's not just 1 in itself, but you have another factor in there. So the number 1 is neither prime nor composite. Determine the prime. Oh, I wish we hadn't seen the answer. Well, we'll let this one be, and I'll just know to kind of be on the lookout for the next one. Determine the prime factorization of 60, right? So 60, you know, I want to work one. Let's work one. Okay. Oh, shoot. I wish you had one. Okay, that's okay. We'll just have to try the next one. Determine the greatest common factor of 2 or more numbers. Write each number as a product of prime factors. Determine the prime factors common to all the numbers, and then multiply the common factors in step 2. Let's see an example. Determine the GCF, the greatest common factor of 90 and 126. Now, didn't we do this already? I feel like we did, but we're going to work it here. Let me get a copy of this and add a page. You going to work? Let's try this again. There it is. So let's get a copy of this. And let's work this out. Okay, let's work this one from scratch. And I'm a fan of my grid paper. And we can go like this, and like this. So we actually determine the greatest common factor of 90 and 126. So the instructions that we just said: first, write each number as a product of prime factors, determine the prime factors common to all of them, and then multiply the common factors, okay? So if we do the 90 first, so if we focus on 90, what times what is 90? Off the top of my head, I know that 90 is what? 2 times 45. But then 45 is what? 9 times 5? 45 is 9 times 5. The 2 comes down, right? But then the 9 is 3 times 3. The 2 comes down, the 5 comes down, right? So the prime factorization of 90 is 2 times 3 times 3 times 5. Okay, so let's do the 126. 126. So now 126 is at least divisible by 2 because it's even. So we're going to say 2 times, let me see, 63. 63 is at least divisible by 3 because the digits add up to a multiple of 3. So this breaks apart into 3 times something, 3 times 21. The 2 comes down. But then 21 is what? 3 times 7. This 3 comes down. This 2 comes down. Okay? So then 90, okay, so now we have the factors of 90 and 26. So then to find the greatest common factor, what we want to do is line up our like factors, okay? So if we look at the 90, we have 2 times 3 times 3 times 5. And then 126, all right, was 2 times 3 times 3 times 7. So I'm aligning my like factors, all right? So then when we go to get our like factors, come on, you're not gonna work. Let's see, I might be able to do a polygon. I'm sorry, I'm just kind of playing around to see if I can get a shape to activate. It did. Oh, wow. You learn something new every day. Look at it. Oh, you learn something new every day. Now I was trying to trip. That was dancing. That was fun. Let me just kind of go ahead and align these. Because once that fills in, style, I wish I could do transparent with this one though. So let me think about it. So if I wanted to do transparent, I would do something like that's fine, like this. I'm gonna do the same thing. Cool. That's exactly what I want. Like this, like that's fine. That one, okay. Style, and we're gonna fill it with this one. Get a lighter color. I like this one best. Okay. Sorry about that. That was just a little adventure. And then let's just copy. Can we just delete that? And let's get rid of all of this too. All right, and then I'm gonna do one other thing. So I'm just totally just playing around. Okay. And this is essentially what I want. Can we stretch it? No. Okay. So that was a fun little adventure. So as we go to find the greatest common factor, we take one of each, whatever they have in common. So they both have at least 1, 2. They both have at least 1, 3, and they both have a second 3, right? So then the greatest common factor is going to be 2 times 3 times 3, right? Which is the same as 2 times 3 squared. 3 times 3 is 9 times 2 is 18. So then 18 is going to be our greatest common factor. All right, let's see, how do we do? Okay, so we got 18, and you see it there, and it's 18. Okay. Yeah, let's just look at it like this, right? So it says to determine the greatest common factor of two or more terms, take each factor, the largest number of times it appears in all of the terms. Okay. Take each factor, the largest number of times it appears in all of the terms. For example, determine the greatest common factor of the terms. We have m to the 9, m to the 5th, m to the 7th, and m to the 4th. The greatest common factor is going to be m to the 4 because they all have at least 4 m's, right? So you take the smallest exponent, right? So m to the 4 is the largest factor common to all terms. Okay. Let's see what's next. So these are steps, okay? So to determine the greatest common factor of two or more terms, determine the GCF of the numerical coefficients of the terms, determine the largest power of each variable that is common to all the terms. The GCF is going to be the product from number 1 and number 2. All right, let's see it in action. Determine the GCF of this. Okay, let's work this one out. So we're going to add a page. I'm going to take this, put it here. All right. Determine the greatest common factor. Let's see. So first, let's focus on finding the greatest common factor between our numbers. So if we focus on, let's do the prime factorization of 48. So now, what times what is 48? I think I want to do 6 and 8. I'm going to say 8 times 6, all right? But then I already know that 8 is 2 times 2 times 2, and 6 is 2 times 3, all right? This is 2, 4, 8, 16, 30, and 18, 48. Okay. So then let's look at 60. So what times what is 60? I'm going to do 2 times 30, right? But then 30 is 2 times 15. Again, this 2 comes down. But then 15 is 3 times 5. This 2 comes down. This 2 comes down, all right? So then 48 is 2 times 2 times 2 times 2 times 3. 60 is 2 times 2. I'm lining up my like factors, times 3 times 5. Then when we go to find the GCF, we want, they both have at least 1, 2. They both have a second 2. And they both have at least 1, 3. Right? So then the greatest common factor of our numerical parts, the GCF there is going to be 2 times 2 times 3. 4 times 3 is going to be 12. Okay. Then if we take our terms, so if we look at our x's, they both have at least 2 x's. So our ultimate GCF, let's just write it here. The final greatest common factor we said was 12. If we look, they both have at least 2 x's, so we're going to say x squared. They both have 1 y, so we're going to say y. The smallest exponent there is a 1. We don't really write the 1. And they don't both have z, so this is what's common to both. Okay, let's cut right here and let's paste. Let's get rid of that. And this one. Okay, so we got 12x squared y. Let's see, how do we do? So the GCF of 48 and 60 is 12. The variable x and y are common to both terms. The variable z does not appear in the second one. So the largest power of x common to both is x squared. The largest power of y common to both is y to the power of 1. So then the GCF is going to be this 12x squared times y. Okay. Let's keep it moving. So To factor a monomial from a polynomial, determine the GCF of all the terms. Write each term as the product of the GCF and the other factors. Use the distributive property to factor out the GCF. So we're asked to factor, we have 15x minus 20. I think I could actually do it here. I'm going to use this color. So we have 15x minus 20. So if we look at the terms, what do they have in common? 15 is 5 times 3, 20 is 5 times 4, so we can factor out a 5. So this is going to be the same as 5 times. Now if we remove the 5 from 15x, we're left with 3x and minus 4, right? And that should be our result there. Okay. And let's actually just move this onto the proper slide. So when we did it, we got this result, and you can see it right next to what they got. So the factor binomial no longer has any common factors, and we can check that the factoring is correct by multiplying, right? So you see it there. Example 4. Okay, let's give this one a go. This one I think I might need a little bit more space. So let's get a copy. And let's add a page. All right. My dog is making some funny sounds. And like she's awake too. She's just like lounging. She's just asleep. She's so funny. She's like, yeah. I was like, are you a cat? What's going on? Anyway. Okay. So we're asked to factor. Okay. So what's the greatest common factor? What do they have in common? They both have at least one q. 8 is what? 4 times 2. And that's 4 times 3. They all have a 4. So we can factor out a 4q from all of them. So then we can factor out, they all have at least 4q, right? From the first one, if we remove 8 divided by 4, we're left with a 2. If we have 3 q's and we remove 1, we're left with q squared. 20 divided by 4 is 5. We have 1 q left over there. 12 divided by 4 is 3, and there's no longer a q there. Notice that this final one, there are no common factors, right? So we would stop here. Oops. So again, as you watch these videos, if anything is not clear, just reach out to me so that and ask. Write it down, email me. I think I do have my Collaborate open right now. So if you were to get on Collaborate, I'm listening, trying to see if someone were to chime in. Oops, didn't mean to do that. Okay. All right, let's keep it moving. So we get 4q, 2q squared minus 5q minus 3. Okay, we got that one. Factor, let's give this one a go. Let's add a page. Okay, so usually when I get things like this, I usually like to start with a copy of the original. We have 6x cubed y squared minus 15x squared y cubed plus 3x squared y squared, okay? So if we look at our numbers, what's the greatest common factor of our numbers? They all have the 3, right? So we can factor out a 3. If we look at our x's, they all have x. They all have y. The smallest exponent on x, we got a 3, 2, and 2, is the 2. The smallest exponent on the y is also 2, right? So they all have at least 2 x's and at least 2 y's. So then we need to write what's left over. 6 divided by 3 is 2. there's one x left there, and I think the y's are gone there. 15 divided by 3 is 5. Both x's have been factored out, and there's still a y left over. And then 3 divided by 3 is 1. The two x's are gone, and the two y's are gone, so we're left with a 1 there. So we know that we know that we get it correct. It's a good idea to go back and multiply back to make sure that it matches out, that they're equal, right? Okay. So again, exam 1 is available. I think it's just over chapter 1. Definitely want to go ahead and get the grade that you want there. That's going to be most of your credit, right? Those exams are worth like 20% of your grade. So you definitely want to do your best. You get unlimited attempts until tomorrow night. Now, the closer we get to the 11:59, probably the internet will slow down. It'll lock up. It'll do all that kind of stuff. So it's definitely a good idea to get these assignments submitted as early as possible. We get 3x squared, y squared, 2x, 5y, and a 1. It looks good. All right, we're going to let that be. All right. So if we're looking at the bottom of the screen, we have this x times 5x minus 2, right? So what do they have in common? So notice the factors, we have something times something else, and the 7 times something else. So if we had, I don't know, I'm going to just kind of let this be. So the greatest common factor here is the 5x minus 2, right? So factoring out the 5x minus 2, we're going to finish with something like this. This factor result no longer has any common factors, and we can check that the factoring is correct by multiplying. So I think what might help this slide is if we incorporate something like this. All right. So we have x times this blue thing plus 7 times this blue thing. So what do these two terms have in common? They both have that blue thing, right? So then essentially what we're doing is factoring out the blue thing, right? We have x times the blue plus 7 times the blue. So then the greatest common factor, what do they have in common? They both have the blue, okay? They both have this blue thing. So then we're going to factor out the blue thing. You see the blue thing here. And so to check, if we were to distribute the blue back into it, if we distribute the blue back in, we'll get what we started with. All right, that's how we would check. Okay. So when you see parentheses, you can kind of think of that as just one thing by itself. Okay. Let's let this be. So that actually closed out section 5.1. So again, I wanted to pause for just a moment. Give it a go yourself, so hopefully you're going through these, taking notes. As questions arise, write them down, email me. You have to reach out to me, because if you don't ask, I can't give you answers with no question, because otherwise I'll just be talking out the side of my neck, right? So it's like, I can't ask the question for you. You have to make your presence known and get your questions asked. And, for professors to, even though professors are supposed to be available, all professors are not available like that. Right, so definitely take advantage of that. That's not a normal thing. It should be, but we don't live in an idealistic world, right? So I just do whatever I can to try to be ideal. Just do the best I can. Anyway, do your best, forget the rest, don't stress, and be blessed. Okay, let's keep it rolling. So we're going to move into section 5.2, factoring by grouping. We use this technique. This is following a polynomial that contains 4 or more terms by grouping. This is the process of factoring a polynomial containing 4 or more terms by removing common factors from groups. This is called factor by grouping. Okay. I'd rather let this one be. I'd rather work something that's a little bit more relevant. So to factor a 4-term polynomial, determine whether there are any factors common to all the terms. If so, factor out the GCF. If necessary, arrange the 4 terms so that the first 2 terms have something in common and the last 2 terms have something in common. Use a distributive property to factor each group of 2 terms and then factor the greatest common factor. Let's give it a go. So we're asked to factor this by grouping. All right. Let's get a copy of this one. This one looks more indicative of or representative of what you're more likely to see. Not to say that first example you won't, but I feel like you're going to see this one more often than not. something of this nature. Yeah, that's all right. I want to add a page. Okay. So let's give this a go. Let's start by getting a copy of the original. I'm going to use this color this time. So we have x squared plus 3x plus 4x plus 12, right? So if we look at the first two, I usually like to do something like this. If we look at the first two, what do the first two have in common? Well, they both have what? They both have x. All right, actually, let's not do it that way. They both have an x. We can factor out an x from both of those, right? And so if we factor out x, what's left over? If we have 2x's and we remove 1, we're left with 1x there. If we have 3x and we remove the x, we're left with just a 3. So now the hint that I would suggest is that we're actually looking for the x plus 3 again in the next set, all right? So if we look at the next set, if we look at the 4 and the 12, what do they have in common? Oh, they both have a 4, so let's factor out that 4. If we factor out 4, we're left with x. If we factor out 4 from 12, we're left with the 3, right? So this light blue part is what is called the common binomial factor. So now we have x times this blue, 4 times the blue. What do they have in common? What color do they have in common? They both have the blue, right? So let's factor out the blue. It's like a reverse distribute. That's how I kind of call this, right? If we reverse distribute or factor out the blue, it's almost like the blues merge. We get this. And then what's left over? So in that first term, if we remove the blue, what's left is the x. If we remove the light blue, what's left is the 4, right? So then we're able to finish here. So to check something like this, why is it behaving like that? Let's try this one more time. Okay. So to distribute or multiply this out, we use a technique called FOIL. FOIL stands for first, outer, inner, last, and we'll see this momentarily, right? But again, to check something of this nature, we would use a technique called FOIL. Okay, let's see. How do we do? So x plus 3 times x plus 4, you see it there. Okay. I am getting a little tired, but let's press on. Let's do this one as well. Okay, if we take this and drop it here, we want to add a page. All right. So now, okay. So we're asked to factor by grouping. Keep in mind that we have 4 or more terms, so we're going to try and factor by grouping. Let's start by getting a copy of the original. So we have 2x cubed plus 4x squared plus 3x plus 6, right? So first, let's group them, right? So if we group the first two with the first two, what do they have in common? Is there anything common to these two? They both have at least a 2. So we could factor out, what, a 2, and they both have at least 2 x's, right? So then what's left over? If we factor out 2x squared, in the first term we're left with an x. In the second term we're left with just a 2, right? The hint is we're actually looking for that same light blue in the second set. So I'm gonna just go ahead and write it just in anticipation, just to see if it works. All right, I'm gonna say, now, if we look at these second two, what do they have in common? They both have a 3, right? So we can factor out a 3. If we remove 3 from here, we're left with x. If we remove 3 from here, we're left with 2, right? So this light blue still worked. Okay. So then they both have the light blue, so we can factor out the light blue here. And what we're going to be left with, in the first term, we're left with 2x squared. In the second term, we're left with the 3. All right, I think that's about it there. All right, in style, we want to go like this. Boom. Okay. All right. Oh, we got x plus 2, 2x squared plus 3. Okay, we got the same thing. I'm just going to use the slides here. So if we group the first two, they both have a q. The second two both have a -1, right? So then we'll get this. We can factor out a -1 from these second two. So if we factor out the q from the first one, you see it here. If we factor out the -1 from the second two, you see it here. Notice they both have the q plus 3. Right? So we can factor out that common binomial factor, that q plus 3, and we're left with q minus 1. All right? Okay. So in this example, if we look at the first two, do they have anything in common? They both have an x, right? If we look at the second two, do they have something in common? Yes, they both have the -2. If we factor out x from these two, we're left with y plus 3. If we factor out the -2 from these two, we're left with another y plus 3, and we should be home free from that point. Y plus 3, we finish here. Okay. So the best way, honestly, so for these discussions, the best way to really learn math, this is not a passive experience. It's really active. You have to do it yourself. The way that you're really going to do it is by doing. It's expected that you do it. You could listen. Honestly, I would just watch the videos just to get ideas or tips or suggestions. But really, you have to do it. And the more you do it, it will become second nature. You just have to do it. If you are just getting in on the lecture, if you're in my support for college algebra, or if you're in any of my classes, I want you to be aware that exam 1 is posted. It is on Pearson. Homework is posted on Pearson. We're doing all of our assignments via Pearson. Also, you can get full access. So if you have yet to get full access, reach out to me. I've been communicating via announcements in Moodle. So what that means is that you want to have your notifications turned on, because that means it's going into your GMC email. If you ignore those emails, you're going to miss some vital information for your everyday life. Okay, that was actually a old TV show reference. I think it was Lori Beth Denberg. She did vital information for your everyday life. I think it was All That on Nickelodeon. I'm totally showing my age. You probably don't get that joke or that reference, but you know, that was just a little bit of nostalgia. But yeah, so again, let's be sure to have our notifications turned on so that as I make announcements in Moodle, you're getting those announcements and you can be updated and stay up to date. But yeah, so the assignment is posted on Pearson. Homework assignments are posted on Pearson. There are quizzes on Pearson. When you log into Pearson and whatever you see there, just get it done. Get her done. The due dates are next to the assignments. And actually, you can submit all assignments past the due date up until a final date, but there will be penalties. So like the highest you can earn on late quizzes and homework, I think, is like an 80%. And the highest that you can earn on like other assignments, like more important assignments, is like a 79%, which is a C. You know, so you definitely want to do the best you can to get them submitted on time. Otherwise, it's okay if you submit it late. Just go ahead and get it in. That's the main thing. Just get it submitted. Okay. So let's keep it moving. All right. Example 12. Let's do this one. This one looks a little bit intricate. But it's the same notion or idea. But let's work it together. So let me start by getting a copy of it. Also, as you work through the homework, if anything is not clear, in the upper right hand corner on Pearson, for each question there's a little button that says question help. You definitely want to make use of that, and in there it's going to say something that says ask my instructor. You want to click on that, and what's going to happen is your email provider will open up and it'll send a screenshot. It'll allow you to type your question, and it'll send a screenshot of the very question that you're working on. What I'm going to do is take that screenshot, load it to my tablet, and I'm going to walk you through it and make a dedicated YouTube video. Trying to get my alignment. I'll make a dedicated YouTube video walking you through any questions that you ask for my students. Okay. Honestly, if I can answer it, it's very easy for me to do this kind of stuff. With the way everything kind of converged as far as availability, technology, internet resources, and all this, it just happened to kind of come together in this light. So very easy for me to do. Just take advantage of it. This is not a normal thing. It might become the norm now that everybody's been forced to be online, but this is what I've been doing for some time now. Okay, so so let's look at this example. We're asked to factor. Okay, so if we look at our numbers, we have 15 and 5. The greatest common, so there is a GCF. All of these terms have something in common, so we can at least factor out. They all have at least a 5. Do they all have X? They all have X. They do not all have Y. The smallest exponent on X is to the power of 1, so they all have at least a 5X that we can factor. All right, and let's start by a copy of the original. 15x to the 4, 15x cubed y, 5x squared y, 5x y squared. Also, oh, people popped in and out. Okay, that's fine. I was gonna say I am monitoring the live chat on YouTube. So if you do have questions, you can actually type in that chat, and I'll kind of glance over there periodically, and I'll respond to questions that I see there. Okay. So we factored out a 5x from all terms. Now, if we do this, we're left with 3x cubed minus 3x squared y plus xy minus y squared. I think that's it, right? Okay. So now we still have 4 more terms. So now we want to use the technique of factor by grouping. So if we look at the first 2 terms, what can we factor out of the first 2? So we have our 5x. Let's see, the first 2 both have 3x squared, right? Let me do it like this. We have 3x squared. Now, if we factor out a 3x squared from those first 2 terms, let's do it this way. So from that first one, we're going to be left with an x minus y, right? Again, when we get on the other side for this factor by grouping, we're anticipating another x minus y. So I'm just going to go ahead and write it. Okay. If we look at the 2 terms on the right, they both have at least one y. So we're going to factor out a plus y, and we're left with x minus y. Okay. There. All right. Okay, and then let's do it like this. So now we want to factor out what color do the 2 terms on the right have in common? They both have the light blue. So we're going to factor out that light blue. So we're going to put it here. We're going to have x minus y. Okay. And then write down the changes. So this 5x comes down. It's just being multiplied by everything. And then we're left with 3x squared plus y. So now this kind of example takes a little bit of practice. It takes practice. Practice makes what? Absolutely not if you said improvement. Absolutely not if you said perfect. Practice makes improvement, right? One of my mentors, that's how he would articulate it. He would say, or that's similar to the way he would articulate it. He would say practice makes improvement. Because if practice makes perfect, then we would never have to do it again. But if we know as humans, once we stop doing something, then the skill level goes down. All right. So once we stop doing something, it goes down, and so it's no longer perfect. But perfection is an absolute. So practice makes improvement. It doesn't make perfect as humans, right? Practice makes improvement. Okay. We get this 5x times x minus y times 3x squared plus y. Let's see, how do we do? Okay, that looks good. All right, so that closed out section 5.2. All right. If we were in each other's presence, I would pause. This will be a time where I would pause for the cause and, open the space for questions. But since we're not live or we're not together, if you have questions, write them down, email me, and and we can kind of go back and forth to discuss them. We're going to keep moving. We have about 2 more sections I would like to get through for today, and we're right on the money on the rhythm that I anticipated. So let's go on to this next section. So we're continuing chapter 5, moving into section 5.3, factoring trinomials of the form ax squared plus bx plus c, where the leading coefficient is a 1. So I'm gonna do a technique where it should be common to 5.3 and 5.4. It's a little bulky and a little cumbersome, but once you master it, it covers more of the scenarios that we'll come across. There is a quick way to do 5.3. I'm gonna let you discover that on your own. But I'm going to show you the technique that once you master it, you get more bang for your buck as far as the technique. If you learn the shortcut first, and then when 5.4 comes up, then you're going to have to readjust again. But the technique that I'm going to offer, once you master or learn it, you get more bang for your buck. Right? So let's look at it. So the objective here is to factor trinomials of the form ax squared plus bx plus c, where the leading coefficient is 1. And we want to remove the greatest common factors from a trinomial, okay? So we want to recall that factoring is a reverse process of multiplication. So if we use FOIL to distribute first, outer, inner, last, we get this thing here, all right? So therefore, this is equal to the original. So note that this is a trinomial resulting in the product of 2 binomials whose first term is x and the second term is a number, including its sign, all right? So where before we started with a binomial times a binomial and we got an answer, now we're going to start with that answer and work backwards to get to the original. Okay. So factoring any polynomial of this form will result in binomials of this form, right? When we FOILed, we said first, so these 2 are the first, these 2 are the outer, these 2 are the inner, and these 2 are the last. So when we FOIL, the 7 was the sum of the 3 and the 4, and this 12 was the product of the 3 and the 4. So then when we factor, we're basically going to work backwards. This constant is going to be, we're going to find the factors that multiply to give us 12 and add to give us 7, right? All right. So I'm going to let you read through this step by step on how to factor a trinomial where the leading coefficient is a 1. And I'm just going to launch into how I would factor it. Well, I kind of wanted to show the longer route, but it's not, you don't really need to do all that here. So I am going to start with the shortcut. It's because this one's just too quick. You just look at it and you can kind of get it. And actually, I don't need to do this either. Let's delete this. So we're asked to factor x squared plus x minus 6. So the result is going to take on the form where we have our double parentheses. We're going to have x and x. We're looking for 2 numbers that multiply to give us negative 6 and add to give us a positive 1. So what times what is 6? 2 times 3, right? We have a 2, we have a 3. And because this is negative, if they're going to multiply to give us negative, that means the signs have to be opposite. So one has to be positive, one has to be negative. And this tells us the sign of the larger number. So the larger number is going to be positive. So if we check, we would check by foiling, but notice that 3 times negative 2 is indeed negative 6. 3 plus negative 2 is indeed positive 1, right? So then we see it here. Okay, let's keep it moving. So let's give, this is a continuation. So then we have the x minus 2 and x plus 3. Okay. Let's try this one. This is still the same. No, this is different, right? So this example, so again, this is going to take on this form, 2 blank parentheses. We got x and x. 2 numbers that multiply to give us 6 and add to give us 1. We got 2 and 3. Because this one is negative, the signs are opposite. This is the sign of the larger number. This one tells us that the signs are opposite. This tells us that the larger number is negative. So this one's going to be negative. This one's going to be positive. 2 times negative 3 is negative 6. 2 plus negative 3 is negative 1. Okay. Okay, let's do this one. So this double blank parentheses, we have x and x. Because this guy is negative, the signs are going to be opposite. So we know one is positive and one is negative. This one tells us that the larger number is going to be negative. We're looking for two numbers that multiply to give us 56 and add to give us 10. 1 times 56, no. 2 times 28, no. 3 doesn't work. 4, here. So let's go through the factors, right? I'll do it over here. So now we have a negative 56, all right? 56 is what? 7 times 8, right? So this is 2 times 2 times 2 times 7 with a negative, right? So then we have negative 1 times 56, but that doesn't add up to, we're looking for the line that adds up to negative 10. We can do 2. If we use a 2, we're left with 28 left over, right? So 2 times 28, but that adds up to 26, so that's no good. There's no 3 here, so we can't do 3. We can do a 4. We do have a 4. If we use 4, we're left with 14. All right. Notice that negative 4 times 14 is negative 56. Negative 4 plus 14 is a positive 10. So the two numbers that we want a positive 4 and a negative 14. So we're going to do a negative 14 here, a positive 4 here. And then we would check by foiling back, right? We would check by foiling. All right, I'm going to move this on this slide now. Okay. So then you see the x plus 4 times x minus 14. Okay. All right, let's keep it moving. Prime polynomials, okay. So a prime polynomial is a polynomial that cannot be factored using only integer coefficients. For example, we have this x squared plus 3x plus 8. It can't be factored using integer coefficients because there are no two integers who multiply to give us 8 and add to give us 3, right? If asked to factor, the correct answer to say that this polynomial is prime, okay? So for instance, if we tried to factor this one at the bottom of the screen, we would be looking for two numbers that multiply to give us 12 and add to give us 5. So we have 1 and 12, but that adds up to 13. We have 2 and 6, but that adds up to 8. And then we have 3 times 4, but that adds up to 7. So those are all the factors. Those are all the factors of 12, and nothing adds up to 5. So then we say that this polynomial is prime. Sometimes each term of a trinomial has a common factor. When this occurs, we factor out the GCF, as explained in section 5.1. The first step in any factoring problem is to factor out the GCF. After factoring out the GCF, we should factor the remaining trinomial further if possible until it's completely factored. Okay. All right. Let's see how. So let's give this one a go. I'm going to work this one from scratch. All right. I am totally sleepy. Okay. All right. So, first question we want to ask ourselves, are there any greatest common factors? It looks like they all have 3 and at least 1 n. So, let's get a copy. We have 3n squared plus 24n squared minus 60n. So if we're going to factor, we can factor out a 3n from all terms. If we remove 3n from the first one, we're left with n squared. 24 divided by 3 is 8, and we're left with 1 n there. 60 divided by 3 is 20, and the n is gone, right? So then we want to factor this trinomial, and we should be able to factor it into something of this form. Okay, we're going to have n and n. Because this guy here is negative, that tells us the signs are opposite. This tells us the sign of the larger number. Okay. So one's positive, one's negative. Two numbers that multiply to give us 20 or negative 20 and add to give us 8. All right, so let's actually just go down the list. So off to the side, we're going to look at the negative 20. Negative 20 is what? 4 times 5, so that's a negative 2 times 2 times 5, right? So let's go down the list. We have 1 times 20, but that adds up to 19. We're looking for the line that adds up to 8, so this is no good. We got 2 times what? 10, and this adds up to 8, so that's what we want. So we're going to have a negative 2 and a positive 10. Okay, and I think we're done with that one. Okay, as you go through these, if you have questions, write them down. Okay, and just you have to reach out to me to get them answered. Okay. And then to check, we would check by foiling, multiplying back. For the sake of time, I'm not going to. 3n times n plus 10, n minus 2. Okay, we're going to let that be. Almost there. Oh, so that actually closed out section 5.3 on factoring trinomials where the leading coefficient is a 1. So now we're essentially going to do the same thing, section 5.4, and this will be the last section for today. It's essentially the same thing. We're going to look at factoring trinomials where the leading coefficient is not 1. Okay, it's a little bit different though, right? So the objective here is to factor trinomials where the leading coefficient is not 1. I'm not going to do trial by error. I'm going to skip that. I feel like trial by error is a waste of time. I mean, you can do it. You can always guess and check, and it's perfectly fine. But I'd rather just show you something that works. If it is factorable, it works. Yeah, we're going to essentially do factor by grouping. That's the gist of it. I'm going to let you go through that on your own. Let me just show you with this one, right? Let me just show with this one. And I'm just going to use the technique that I use. I don't really... I stopped doing trial and error. I mean, and there's nothing wrong with it. I just remember when I first started looking at this stuff and I was doing a presentation on it, and I was trying trial by error, and I just kept going back and forth because I felt like it was factorable, and I wasted a lot of time trying to figure out before I realized that it wasn't. So the technique that I'm going to show, you'll know whether it's factorable or if it's prime, right? Trial by error, you could potentially waste a lot of time and kind of be stuck, right? So I usually like to start by getting a copy of the original. 3x squared plus 20x plus 12, right? First question we want to ask ourselves is their greatest common factor. It might be 3, but they do not all have 3, so there's no greatest common factor. So now what we want to do, in the past, we were looking for two numbers that multiply to give us 12 and add to give us 20. But in reality, it's two numbers that multiply to give us, 36 and add to give us 20. It's just in the previous examples, the leading coefficient was a 1, so we kind of ignored it. Okay, so let me get rid of those. So we're really looking for two numbers that multiply. If we say the a times c, 3 times 12 is 36. We're actually looking for two numbers that multiply to give us 36 and add to give us 20. Now 36 is what? 6 times 6? And so that's 9 times 4, right? So we're going to say 2 times 2 times 3 times 3, right? So we're going to go through all the factors of 36, and then we're going to stop at the line that adds up to 20. So first we have 1 times 36, but that adds up to 37, so that's not what we're looking for. We can do 2, right? If we use this 2, notice that we have 18 left over. So if we use the 2, we have 18 left over, but that adds up to 20. Those are the two numbers that we're looking for, right? So what we're going to do, we're going to rewrite this 20. We're going to rewrite this guy using those two numbers that we just found. So we're going to rewrite the 20 as, and I'm intentionally going to put this 18 next to the 3 and this 2x next to the 12, right? I'm intentionally putting like terms side by side, or terms that have common factors, right? Side by side, right? So then now we're primed to use the technique of factor by grouping. So if we group the first two, what do the first two have in common? Actually, I'm gonna leave the factor by grouping as a exercise for you. I'm gonna use this technique. It's called the box method. It is on YouTube. And I think I got it from my students. I'm just gonna use this technique though. So I'm gonna create a box in this fashion. Let me think about it. What else am I? I guess we could just do a box and that'll be fine. Let's move you like this way. So, okay. So now what we want to do, in the upper left-hand corner, in the upper left-hand corner, we have our 3x squared. In the bottom right-hand corner, we have our constant, which is the 12. And then we want to take those two numbers that we want to take that 20 and that 18 and that 2, we want to put those in the other diagonal. So we're going to put let's get rid of this guy. We're going to put our 18x here and our 2x here, right? So if we look at the two on the top, what do the two on the top have in common? They both have 3x. What about the two on the bottom? They both have a 2, right? The two on the left both have at least one x, and the two on the right, is it 6? They both have a 6, right? So then our claim is that the original factors into x plus 6 times 3x plus 2. Okay. And so we could check. We can check by multiplying back, foiling, and we should get the original. For the sake of time, I'm not going to expand it. I'm going to leave that for you. Okay. So again, if anything is not clear, you have to reach out to me. If you don't ask, I can't answer questions that aren't asked. All right? Okay. All right. We're actually almost done, and we're going to wrap it up. Okay. So let's see. We got x plus 6 times 3x plus 2. X plus 6 possible. Oh, that's the trial and error, right? I'm not really a fan of that. Yeah, I'm just going to let that be. Is this the one that we just... Or is this the same one? Or is this a different one? Oh, is this a different one, right? Example 6? Well, it's a serious jump. Oh, I see. Sure, let's do it. I'm kind of tired. I'm going to let this one be. I think it'd be easier to just do it, though. Okay. So if you are live, I don't know if you do like numerology at all or not, but it's just about 11:11 over here. Okay, that's neither here nor there. So let's give this one a go. We want to add a page like this, boom. Okay. Ooh, give me just a moment. Matter of fact, oh, I can't get that to go away. Oh well, I'm not gonna worry about that, man. I was gonna try to get a screenshot, but that's okay. Okay. So now let's factor this one. So this one is a little different because the last term has a variable in it, but we essentially do the same thing, right? We're not really doing anything that different, but I decided to work it because I do realize that it might throw people for a loop. So now we're going to essentially do something similar. two numbers that multiply to give us, instead of just 3, 6 times 3 is actually 18. We got to do A times C. So two numbers that multiply to give us 18. Okay, and add to give us 19. And I think you see it off the rip, right? So it's basically 1 and 18, right? So we're going to rewrite that 19 as 1 and 18. I'm going to put the 18 with the 6, right? So I'm going to rewrite 19 as plus 18xy plus 1xy. Okay. And then I'm going to bring everything else down. So the 6x squared comes down and the 3y squared comes down. And actually, I'm going to do the box technique again. I'm just a fan of it. So I'm going to start with the box. All right. Let's see. So in the upper left-hand corner goes the 6x squared, and the bottom right-hand corner goes the 3y squared. There's no GCF or anything. Yeah, there's no greatest common factor. So then the two numbers that we found go on the other diagonal. We're going to have xy, and we're going to have 18xy. So if we look at the two on top, what do they have in common? They both have at least the 1x. They both have an x, right? What do the two on the bottom have in common? They both have a 3 and a y. All right. What about the two on the left? What do they have in common? They both have a 6x. And the two on the right both have just the y, right? Two on the bottom have the y. So then our claim is that the original factors into 6x plus y times x plus 3y. And again, you could it's definitely suggested that you go back and check. You would check by FOILing out. So if you multiply, if we expand it out, we should get back to the original. For the sake of time, I'm not going to expand it, okay? 6x plus y and then x plus 3y. 6x plus y, x plus 3y. Okay. Yeah, I'm just not gonna do the guess and check. I feel like that's overkill and it's a waste of energy. But it's nothing wrong with it. I'm just not a fan of it, so I'm not gonna do it. But guess and check is like you would make your answer and then you would multiply back to make sure that it works or not. And you just kind of go through. All right. So this is the technique that we've been doing by grouping, okay? So I'm going to let you read through this on your own. And I'm going to I think I'm going to leave, I'm just going to kind of do a quick scan because this is going to be a repeat of what we've been doing. I'm going to scan to see if I see anything that's different that we haven't really done. Okay. But yeah, so if anything is not clear, or if you need, is there any, it's no common factor. Yeah, I'm just going to, this is still kind of a repeat, right? So I'm just going to let you kind of get to that one on your own. Okay. So I would say give these a go, work them yourself. Yeah, I'm going to actually just let that be. Add a page, okay? And let me do this, paper. Yeah, and if you need me to go through and work through any example or any homework question, just let me know, okay? So with that, I think that concludes what I would like to talk about for today. Just as a quick recap, so that was an introduction on some factoring techniques. We talked about greatest common factor, factor by grouping, factoring trinomials where the leading coefficient was 1, and factoring trinomials where the leading coefficient is not 1. There are homework assignments associated with this. It looks like a lot of work. If you just, at first glance, it looks intimidating, but it actually goes fast once you get the hang of it, okay? So check out the homework on Pearson. Also be aware that exam 1 is available on Pearson and is due Saturday tomorrow by 11:59 p.m., okay? I'm available for questions, so you can ask me questions. Get your assignment submitted. I would probably exam 1 is over chapter 1. If you feel ready, I will go ahead and just knock that out. We get unlimited attempts, so you can get whatever score that you want to get on these assignments before they're submitted. All right. Once the due date hits, then you can still submit it, but it's going to be a penalty. All right. The best thing is just to get these assignments submitted on time. Okay. Okay, I can't think of anything else. Again, as you have questions, write them down and reach out to me. I'll be available. Okay. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace. You. So I do that because I actually am inspired. I'm totally inspired by like Infinite Waters, Ralph Smart. This brother's phenomenal. Like I'm trying to be similar to him. He's also Pisces as well, and he's been submitting content via YouTube like almost every day for a long time. I mean, some years. I'm talking years. And like he's essentially freed himself from the matrix by doing what we're doing now. He's talking about what he enjoys and is relevant, and people seem like they really appreciate what he talks about. Also, my presentation, I've actually been inspired by like gamers. I definitely encourage people to be clear about what it is that you love to do. So once you're clear about your passion, like what excites you, what gets you out of bed on the day to day, do it. I encourage people to, as long as you're not infringing on anybody else or harming anybody else or yourself, I encourage people to follow their passion, because you never know how these things are going to manifest or come out, and like how you never know how you're going to help somebody, how you might save your life or anything of that nature. So as long as you're not infringing on the rights or personal space of somebody else or yourself, and it gets you out of bed every day and it gets you excited, do it as much as possible. But yeah, and so I'm all about freeing yourself doing what you love to do. I have too many people, too many loved ones that day in and day out, they go to these jobs where they're miserable. And like, it's like they're just alive just to work. And like, that's not, what kind of life is that? Like, that's not, I don't really recommend that for anybody. But to me, the mark is where you can get paid to do what you love to do and you never work a day in your life. That's just how I feel about it. So I'm not really an authority. I'm just sharing my perspective or my angle or what my experience has been, right? And what's helped me along my way. So definitely shout out to Infinite Waters, Ralph Smart, phenomenal brother. He has some powerful information on just basically, becoming your greatest version, from relationships to letting things go to all sorts of things. It's very phenomenal information. And then, I just encourage people to be clear about your passions and do it as, do your passions as often, as much as you can. And eventually you become so good that it becomes like art and people starts to pay you to do what you're passionate about doing. I'm all about that. So again, on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace. See ya.